Today the topic for discussion is interpolations. We see some operators first. So y is equal to fx is the given function, and the values of x are x naught plus h, x naught plus 2h, x naught plus nh are called arguments, and these values are equally spaced because the difference between x naught and x naught plus h is h. Similarly, the difference between x naught plus h to x naught plus 2h is again h. So the distance between each 2 points is what? Is h. That is, these values are equally spaced. That is, if you have to find next value, then add h, and if you have to find previous value, then subtract h. That is, what is the value of x before x naught plus 2h? Subtract h from x naught plus 2h, and is what? X naught plus h. What is the previous value of x? X naught plus h. Subtract h from x naught plus h, and the value is x naught. Similarly, the previous value x naught is what? X naught before x naught. What is the value of x? X naught minus h. Then what is the previous value? X naught minus 2h. So if you have to find previous value, then subtract h, and if you have find the next value, then add h. So these values of x are what? Called argument and are equally spaced. Okay, and this y is equal to fx is the given function. So, and the value of this y or fx at x naught is what? Is denoted by y naught or f of x naught. So what is f of x naught? F of x naught means value of f function f at x naught, while f of x naught plus h is the value at x naught plus h, and this is denoted by y1. So what is y1? Y1 is f of x naught plus h. That is the value of the function y or fx at x naught plus h. So what is the y naught? Is f of x naught, means the value of the function f at x naught. Similarly, what is y2? Y2 is the value at x naught plus 2h. So these are the values of y or fx at these points. So what is f of x naught minus h? So f of x naught minus h is y minus 1, y suffix minus 1. So what is y1? What is y2? What is yn? So what is yn? The value of the function y or fx at x naught plus nh. So this is yn. So these both notations are same. That is, instead of f of x naught, we can write y naught. So what is f of x naught plus h in another form is y1. So y1 and f of x naught plus h both are same. So what is f of x naught plus 2h? So y2. So remember these all notations. We solve the problems in both notations, that is y naught, y1, y2, yn. Also we solve the problems in the notation f of x naught plus h, and so on. So the first definition and the first operator is forward difference operator. It's called forward difference operator or leading difference operator, and the notation for forward difference operator is delta. This triangle means read it as delta. So this is the notation for forward difference operator, delta. So what is the definition of delta fx? Is what? F of x plus h minus fx. That is the value of the function at next point. What is the next point of x? Is x plus h. So how we can obtain the next point? By adding h in that point. Okay. So delta fx is what? F of x plus h minus fx, means what? The next value of the function at next point minus value at the same point. So learn this definition, that delta fx. What is delta fx? Is the value at next point minus value at the same point. Okay. So what is delta in this fashion? What is delta f of x plus h? The delta f of x plus h is what? F of x plus 2h minus f of x plus h. That is the next value at next point minus value at the same point. Okay. So In another notation, what is delta y naught? Is the value at the next point, means y1 minus y naught. So this is delta y naught. What is y naught? Y naught means delta of f of x naught. So what is delta of f of x naught? Is f of x naught plus h minus f of x naught. That is y1 minus y naught. So learn this in both notation. That is, we can write this delta y naught is equal to y1 minus y naught in another fashion, that delta f of x naught is what? F of x naught plus h means y1 minus f of x naught, the value at the next point. Similarly, what is delta y1? Is the value at the next point, that is y2 minus value at the same point y1. So in another notation, delta of y1 means delta of f of x naught plus h. What is delta of f of x naught plus h? Is f of x naught plus 2h minus f of x naught plus h, means y2 minus y1. Similarly, what is delta y2? The value at the next point, means the next point is what? y3 and minus y2, the same value at the same point. So in another notation, what is delta of f of y2? Means delta of f of x naught plus h, x naught plus 2h. What is delta of f of x naught plus 2h? Is y3 means what? F of x naught plus 3h, next point, okay, and minus f of x naught plus 2h. So in this fashion, delta of yn minus 1 is what? Yn minus 1. So these are the first forward difference, or is called forward difference operator delta. This is the definition and meaning of forward difference operator. So delta square fx. What is delta square fx? Is delta of delta fx. Delta square means delta into delta. So delta of delta fx. Now what is delta of fx? Delta of fx is f of x plus h minus fx. This is delta fx. The value at the next point minus value at the same point. That is, delta of fx is what? Delta of fx is f of x plus h minus fx. This is the delta fx. And then multiply by this delta, or operate this delta on both. That is delta f of x plus h minus delta fx. Again, what is delta f of x plus h? Is the value at the next point, means f of x plus h. What is the next point? X plus h. The next point is what? X plus 2h. Add h. So f of x plus 2h minus f of x plus h, the value at the same point. So this is delta f of x plus h minus, in bracket, write in bracket, that write in bracket, here write the bracket, that f delta fx. What is delta fx? Is f of x plus h minus fx. But because of this negative sign, the first term becomes negative and the minus f of x becomes plus f of x. So either write here bracket and then write here minus sign, or directly minus and this is the plus sign. Okay, so what is delta fx? Is again f of x plus h, the value at the next point minus value at the same point. So because of this negative, we have here positive. Okay, and then add these two terms, both are same. So this is f of x plus 2h minus f of x plus h plus fx. This is the delta square f of x. Similarly, you can find delta cube of fx. What is delta cube of fx? Is delta square of delta fx. Delta square of delta fx. And what is delta fx? Is f of x plus h minus fx. And then operate delta square on both, and then write this delta square f of x plus 2h, and delta, again find this delta square f of x plus 2h by using delta of delta f of x plus h. Again, this delta square fx is what? Is delta square fx is delta of fx. So solve this, we have this answer. So these are in the notation of fx. But in the notation of y, what is delta square y naught? Is delta of delta y naught. And what is delta y naught? Is y1 minus y naught. So operate delta on both. What do we have? We have delta y1 minus delta y naught. What is y1 minus y naught? is delta of y1, y0. What is delta of y0? Is y1 minus y0. So apply delta on both. So delta square y0 is what? Similarly to this, delta square of y0 is what? Delta of y0, and delta of y0 is what? Y0 minus y1. Similarly like this. Okay, and delta y1 is what? Y2 minus y1, the value at the next point minus value at the same point, minus, write in bracket, y1, what is delta of y0? Is y1 minus y0, the value at the next point minus value at the same point. And so by applying this negative side on this bracket, what we have, this is negative and this term is positive, plus y0, and this minus y1 and minus y1 becomes minus 2y1. So both these answers are same. These answers are same, but this is in the notation of fx and this is in the notation of y. So in the same fashion we find delta square y0, delta square y1. In this same fashion we find delta square y1. So what is delta square y1? Is delta of delta y1. And what is delta y1? Is y2 minus y1. So apply delta on both. What we have? We have this delta y2 is what? Y3 minus y2. The value at next point minus value at the same point, minus delta y1 is what? Y2 minus y1. Okay, the value at next point, and then we have this answer. So this is delta square y1. So these are the second differences. Similarly, we can find third differences, fourth differences. So what is delta cube? How can we can find delta cube fx? Similarly to this, delta cube fx is what? Is delta square of delta fx. Delta square of delta fx, and delta fx is what? F of x plus h minus fx. Then apply delta square and then find delta square f of x plus h in this way, and then delta square fx, and we get this answer. Okay, y3 minus 3y2 plus 3y1 minus y0. Either apply obtain the answer in the format of what? Y or fx. Okay, so the next is the algebra of this delta. So delta, how we can apply delta on this fx into gx? So delta of constant is 0. The first note is what? The delta of constant is 0. Like derivative of constant is 0. Like that, delta, actually this delta is what? Of constant is 0. What is delta fx into gx? Is f of x plus h into delta fx plus gx delta fx. This rule is similar to the rule u into v rule of the derivative. What is the derivative of fx into gx? What is the derivative of fx into gx? Is fx derivative of gx plus gx derivative of fx. So this is similar to, this rule is similar to u into v rule, but change is what? Here is instead of fx, there is f of x plus h. Sorry for trouble. My Microsoft PowerPoint not working properly. Yes, again started PowerPoint. This is the rule for similar to u into v rule. Okay, what is the derivative of u into v? U derivative of v plus v derivative of u. Like that. What is the derivative of fx into gx? Is fx derivative of gx plus gx derivative of fx. So what is delta? Similar to that, but only this is not fx, this is f of x plus h. So remember, particularly this is not fx. So fx delta gx plus gx delta fx. So, and this is the second rule, that the rule of division. So what is the rule of division for derivative? That is derivative of fx by gx is what? Gx, or derivative of u by v. What is the derivative of u by v? V derivative of u minus u derivative of v divided by v square. So instead of v square, instead of this gx square, there is gx plus h into gx. So what is the delta of fx by gx is gx, that is v, into delta of fx, that is delta of u, minus fx, that is u derivative of v, like that, delta of gx, divided by, instead of gx square, there is gx plus h into gx. So we have to prove these two rules. So the proof for second rule and the proof for first rule remains for homework. So the proof of second rule, that delta of fx by gx is this. So what is delta fx? What is the definition of delta fx? The value of that function at next point minus value of the function at the point. Okay, so instead of if you find delta of gx, what is delta of gx? Is gx plus h, that is the value of gx at next point minus gx. Okay, so what is delta of fx by gx? This is one function, considered as a one function. So what is the value of what is the delta of this function fx by gx? Is the value at next point of this function f of x plus h f of x divided by gx. What is the value of this function at next point? Is this f of x plus h divided by gx plus h. So like delta fx is what? F of x plus h, means value of this function fx at the next point, fx by gx. What is the value of fx by gx? At next point is this f of x plus h divided by gx plus h, and minus the value at the same point. Okay, so don't write this as fx plus h minus fx divided by, this is not in that form, divided by gx plus h minus gx. This is value of what? Delta fx by delta gx. This is not delta fx by delta gx. This is what? Delta of fx by gx. And is what? The value of this function at next point, that is this f of x plus h, replace only x plus h, x by x plus h, minus value at the same point. Okay, that is f of x by gx. So don't write here that f of x plus h minus fx divided by g of x plus h minus gx. That is the value of delta fx divided by delta gx. And this is not delta fx by delta gx. This is delta of fx by gx. So this is the value at the next point of this function fx by gx minus value at the same point. And then take this gx plus h into gx as LCM, then cross multiplication, f of x plus h into gx, this term, minus gx plus h minus fx. Okay, into fx, gx plus h into fx. Okay, then subtract and add this term. What is the term? This f of x plus h gx as it is, subtract f of x gx and add fx plus gx. This term minus gx plus h fx as it is. So both these terms are as it is. And what is the change? Subtract this term fx into gx and add fx into gx. This term get cancelled, then we get this step, this numerator. Okay, so this term as it is, f of x plus h into gx minus f of x gx. So here subtract the same term, add the same term, so no effect, and minus gx plus h into fx as it is, divided by gx into gx plus h as it is. Then take this gx as common factor, then we have in bracket f of x plus h minus fx. Here wrongly write gx, here is not gx, here is fx. So write here at this place f, minus take this fx as common factor. So what do we have? Gx plus h minus gx, and divided by gx plus h as it is. And what is next step? Next step is what? This gx, right? The next step is this gx, and this f of x plus h minus fx is delta fx, minus this fx, and this gx plus h minus gx is delta gx, divided by gx plus h. That is, we get this step. So right after this step, write equal to, write one more step, gx, this is what? Delta fx minus fx delta gx, divided by gx plus h. Okay, So in the next lecture, we will see this backward difference operator, similar to uh, forward difference operator. This is the backward difference operator, and this is what, this is the notation for backward difference operator is what, del. So what is the definition of del fx? Is this the value at the same point minus value at the previous point. So in next lecture we'll see the further two operators, backward difference operator and forward difference operator. So